Hello everyone. Today I want to talk about the compressive fatigue testing new approach. These are the outlines that I want to talk about. The introduction to the project, the use of concrete in offshore wind turbine structures, brief introduction to the fatigue testing and database, the reason for the variations, and recommendation of a protocol for compressive fatigue. So this project is funded by Department of Energy, and it's for considering or investigating the effect of fatigue on the capacity of structural concrete in wind turbine structures. Here we see some use of concrete in wind turbine structures. We have concrete towers in onshore wind turbine. Gravity-based foundations in fixed-based bottom offshore wind turbines, floating foundations, and also the gravity-based anchors for floating offshore. So for compressive fatigue, we are using cylindrical specimens with 4-inch diameter and 8-inch height, and we are measuring the strain around the perimeter. So in this plot, we see the stress on the vertical axis and strain on the horizontal axis. The curve shows the monotonic response of the concrete to the static standard loading with the loading rate of 35 psi per second. And in fatigue loading, we are doing constant amplitude testing with a minimum and maximum stress, which is a ratio of the strength of concrete. And it will go, and you will see some results here that shows the stiffness degradation through the process and up to the failure. So for fatigue, to estimate the design life, we have SN models, which represents the number of cycles to failure on the horizontal axis, which is a logarithmic base, and we have the stress ratio on the vertical axis, which we have here, the model code, FID code, and S-max is the ratio of maximum applied stress in the cycle divided by monotonic strength. And for each S-mean level, we have different curve. So we have gathered a database from the previous works, and almost all the test data is within that red cube that I showed there, and that's because the line that we show there is about 1 million cycle. 1 million cycle with frequency of 1 hertz takes about 2 weeks. So it's costly and takes time, so most of the test is below that. So this figure shows the SN model that we have from DNV, model code, and world code, 3 different codes that people use in offshore wind sector, and we have some results with different research with estimate of 5%. The range of result is very much. So you could see models themselves have some difference in predicting the life, and that's because each model is based on a particular data set. If you see the 0.8 S-max level, you can say your specimen can last this level of loading cycle 100 cycles or 100,000 cycles. So a thousand factor of difference in predicting. This is the same plot with different S-mean ratios, with different colors and dots, and you see these ranges, and this wide range is existing in different loading level. So we are recommending a new approach to set this loading. So for setting the loading, we are using the strengths. If we do 5 good, monotonic tests, we take the average, and based on that, we define the loading of constant amplitude testing. For a normal concrete, the coefficient of variation of the strength is about 2%. It means that 5% below, plus or minus. So if you see in this, let's say we take the average strength And we assume that we are looking in this 20% in this load. The model shows that our concrete will last 10,000 cycles, and we said 1,000 cycles, we also said about 2,000 cycles. If we were not correct, and 5% less strength, 5% less strength, the S-max is not 80%, it's 84%. And model code says it's less than 2,000 cycles. It's 5-fold difference in the model itself. So we are suggesting to guesstimate the strength. So we do 5 standard monotonic tests, and we find the average strength. Based on that, we define the S-max. We load up to S-max with the standard rate of loading for monotonic test, which is 35 psi. And based on that, we go back to the mean of our amplitude, and based on that, we plot it with this monotonic responses that we have, and we see the line that we have fits to which one of those monotonic responses that we have. And based on that, we guesstimate our strength, and then we start our fatigue testing. This is another plot for 3D printed concrete. In 3D printed concrete, the variation is very high. It's plus or minus 50% or almost 30%. So having a sense of strength would affect the result a lot. This plot shows a SN curve. I'm showing the model code, DNV, and Eurocode, and we have 2 sets of data from previous work in University of Hanover and University of Illinois. You see the broad range of results. They assume the average strengths, and based on that, define the total. We did 3 different concretes, saturated, dry, with different strengths, with different aggregate characteristics. We did some tests, and with this recommended protocol, the range of result is much more or less. Also, right now, so it proved that our method is working. Right now, we have tested 3 different mole concrete, lightweight aggregate, concrete with crushed granite aggregate, concrete with river round aggregate, and currently tests are ongoing. So in each concrete type, we have about 80 cylinders. So we will have more test results by the next convention to prove this method is working. And we are preparing a tech note for fatigue committee based on these results. And if it passed and if we get a good feedback, it will be published. And then we are going to do some X-ray scanning for the fatigue testing that we are doing to see the internal crack propagation due to the fatigue testing during test, and see if we could make a link between this X-ray and the strain evolution due to the fatigue. It might be useful for existing structures if we could take a core from hot spots and then do X-ray. We could see if we can see how much light is remaining. So the takeaway is that this recommended method will help us to reduce the range of results, and then there is a need for standardized methods of testing for fatigue. With that said, thank you for ACI, and thank you for the